Today we're going to talk about linear inequalities and continue along where we left off. The compound inequalities are the ones that involve more than one solution interval. The intersection of two sets, like A and B, is written with this upside down U, and it's a set of elements common to both sets. And the intersection of two sets can be used by describing with the word AND, where it has to be in both inequalities. The union of two sets, it looks like this U value in the middle, that's the symbol for union, is a set of elements that are in either set. The union of two sets is described by using the word OR. It can be in either of the inequalities. A couple examples: if this is set A with -2, -1, 0, 1, 2, and B has the numbers 1, 2, 3, if we're looking at the intersection of sets A and B, what's in both sets, that would be the numbers 1 and 2. If we're looking at the union, that's a set that's in either A or B, then it's going to be everything in A and everything in B, which is -2, -1, 0, 1, 2, and then also what's in set B is the number 3. Looking at some examples that are in inequalities. We're going to solve this by looking at a number line starting at -1 up to 3. You can do these individually above the number line. If you're thinking in terms of greater than or equal to -1, that would include the -1 and be everything to the right of it. If it's less than 3, that would be not including the 3, but everything below it. And we're looking at the word and means it has to be in both sets. That means it's 1 including the 1 all the way up to 3, but not including the 3, and everything in between. That's the graph of it, and then if you write it in interval notation, that would be the set of x with all the elements from -1, including the -1, all the way up to 3, but not including the 3. If we use the same idea with the next one, we're going to have the numbers for -1 and 6 are the critical values. We're looking at the numbers that are less than -1. That would not include -1 and go everything to the left. It would be everything greater than or equal to -6, includes the +6, and then everything to the right of it. And we're looking at anything that's in either one of these sets. That would be everything we drew so far. So it's not including the -1, but everything to the left. It does include the 6, and it's everything to the right. And if we're writing this in interval notation, it's a set of x such that the elements are from -infinity all the way to the -1, not including -1, or it's from 6, including the 6, all the way to infinity. If we look at the next one, we're going to have to do a little solving first. We have 4x. If we subtract 5 from both sides, we get greater than or equal to -4. And if we divide both sides by +4, you get x is greater than or equal to -1. If you also look at this as another AND equation, if we look at this one and we subtract 3 from both sides, we're still left with -x on the left, and then 1 minus 3 on the right is -2. We're going to divide by -1. That's not only going to change the signs of both x and -2, but it also flips our inequality to now be a less than. And this is an AND. So again, our critical values are -1 and +2. It's going to be everything that is greater than or equal to -1, which is to the right, and then less than 2, which does not include the 2, and everything to the left. And that means that it's going to be including the -1 all the way up to the 2, but not including the 2. If you look at that solution that's in example 4, it's that single interval between -1 and 2, and the original inequality could also be joined to be written in the format of -1 is less than or equal to x, which is less than 2. This is called a joint or a compound inequality, because you can put two things in one. And the last example is one actually using that joint or compound inequality thought. This is an inequality that has bound by two inequalities here. So the first thing we're going to do is try to get this x by itself. That -2 is being divided in the middle, so we're going to do the opposite, and we're multiplying all three sections by that same -2. So negative 2 times 2 is negative 4. The middle section, the negative 2 in the bottom is canceling, and the other section is 8. Now, when you're multiplying or dividing by a negative, these inequality signs will flip over. We're still trying to get x by itself, so the next thing we want to do is get rid of this 2. We're going to subtract 2 from all 3 sections. In the middle, it's gone. We're left with negative 6 is less than 3x is less than or equal to 6. Then the next step, we want to still get rid of this 3, so we're going to divide everything by 3. On the left, we're going to get negative 2 is less than x is less than or equal to 2. This is bound in between negative 2 and 2. The critical values are at negative 2 and positive 2. It's not going to equal the negative 2. It is going to equal the positive 2, and it's everything in the middle. If we write this in set notation or integral notation, x is an element from negative 2 all the way to positive 2, including the positive 2.